Welcome to Maths Companion. Today we are going to start a new chapter which is very interesting and which has got a high practical value. By the early 19th century, explorers had discovered most of the world. Trade and transportation was booming between distant countries, and this created a need for accurate maps of the entire planet. Today, we have satellites that can take photos from above, but 200 years ago, creating maps was a difficult and time-consuming task. It was done by mathematicians like Radhanath Sikdar. Of particular interest was the quest to find the highest mountain on earth. There were a few different candidates, but from hundreds of kilometers away, it was difficult to tell which one was the highest. So, how do you measure the height of a mountain? Today, we can use satellites to measure the height of mountains to within a few centimeters, but these did not exist when Radhanath was surveying India. Radhanath Sikdar was an Indian mathematician. He was the first to measure the height of Mount Everest and to show that it is the tallest mountain on earth. Today, we are going to learn a chapter which helps us to find the height of a mountain or a tree and the width of a river, etc. And the name of the chapter is Trigonometry. The word trigonometry is derived from two Greek words, trigonon and metron. Trigonon means triangle and metron means measurement. So the word meaning is measurement of triangles. Before we start the lesson, let us recall some basic ideas which we have already learned. That will help us to understand this chapter easily. This is a right angle triangle and this side is called base, this is called height or altitude, and this is called hypotenuse. And we know hypotenuse square equal to base square plus height square or base square plus altitude square. You know how to find square root. One method is factorization method. 9 equal to 3 into 3. Therefore, root of 9 equal to root of 3 into 3. There are two 3's within this root sign. So, we can take 1 out of the root sign. Then we get root of 9 equal to 3. Now, suppose we want to find the square root of 27. Let us factorize 27 at first. When we divide 27 by 3, we get 9. Again, if we divide it by 3, we get 3. That means 27 equal to 3 into 3 into 3. Therefore, root of 27 equal to root of 3 into 3 into 3. For two 3's, we can take 1 3 outside. Then only 1 3 remaining, that will be within the root sign. So, root of 27 equal to 3 root 3. In an isosceles triangle, the perpendicular from the vertex joining equal sides bisect the angle at this vertex and the side opposite it. Suppose this is an isosceles triangle and AC and BC are equal. Then this is the vertex joining equal sides. From this point, if we draw a perpendicular to this side like this, then this line bisects this angle and this side. That means angle ACD and angle BCD are equal and AD equal to BD. This is a side of the triangle and this is the height to this side. Then area of the triangle is half BH. Now let us take a parallelogram. This is one side and this is the distance from that side to opposite side. Let it be H. Then area of the parallelogram is B into H or BH. If A is to B equal to C is to D, then AD equal to BC. That is product of n terms equal to product of middle terms. Now let us start the first section of this chapter, angles and sides. Consider a right angle triangle. Suppose this angle is 45 degree. Then what is this angle? We know sum of the three angles of a triangle is 180 degree. This angle is 90 degree. Therefore, the sum of the other two angles is 90 degree. Since this angle is 45 degree, this angle is also 45 degree. That means in a right angle triangle, if one angle is 45 degree, the third angle is also 45 degree. Now look at the triangle. Two angles are equal. So it is an isosceles triangle. Already we have seen that it is a right angle triangle. Now we have seen that it is an isosceles triangle. So this triangle is called an isosceles right angle triangle. That means at the same time it is isosceles and right angled. How can we identify an isosceles right angle triangle? One angle is 90 degree because it is a right angle triangle. And since it is an isosceles triangle, two sides are equal. So we can define an isosceles right angle triangle like this. A triangle in which one angle is 90 degree and two sides are equal. We have also seen that in an isosceles triangle, two angles are equal. So we can define like this. A right angle triangle in which two angles are equal is called an isosceles right angle triangle. And we have seen that when two angles are equal, they are 45 degree each. So we can say like this also. It's a right angle triangle in which two angles are 45 degree each. And we have also seen that if one angle is 45 degree in this triangle, the other angle is also 45 degree. So we can say like this also. An isosceles right angle triangle is a right angle triangle in which one angle is 45 degree. Because we know if one angle is 45 degree, the other angle is also 45 degree. So these are all different ways by which we can understand or identify an isosceles right angle triangle. Simply we can say it's a right angle triangle and there are two equal sides. Suppose this side is 3 cm. Since it is an isosceles triangle, these two sides are equal, therefore this is also 3 cm. Now let us find the third side. Third side is the hypotenuse of this right angle triangle. So we know hypotenuse equal to root of base square plus altitude square, or the third side equal to root of 3 square plus 3 square. And we know 3 square is 9, so this can be written as root of 9 plus 9. 9 plus 9 means 2 times 9 or 2 into 9. So this can be written as root of 2 into 9. In 9th standard, we have studied that root of AB equal to root A into root B. So this can be written as root 2 into root 9 or root 2 into 3, or we can write it as 3 root 2. That means when this side is 3 cm, this is 3 cm and this side is 3 root 2 centimeters. Now let us change the side. Instead of 3 centimeters, let us take 4 centimeters and observe what happens. Another isosceles right angle triangle, and this side is 4 cm. These two sides are equal, so this is also 4 cm. Now let us find the third side. It is the hypotenuse. We know hypotenuse equal to root of base square plus altitude square, or the third side is equal to root of 4 square plus 4 square. And 4 square is 16. So this can be written as root of 16 plus 16. 16 plus 16 means 2 times 16. So this can be written as root of 2 into 16. Root of 2 into 16 can be written as root 2 into root 16. Root 16 is 4. Therefore, this can be written as root 2 into 4 or 4 root 2. That means when this side is 4, this side is 4 and this side is 4 root 2 centimeter. We have seen that when base is 3, altitude is 3 and hypotenuse is 3 root 2. When base is 4, altitude is 4 and hypotenuse is 4 root 2. That is, the hypotenuse is root 2 times base or altitude. Is it always true? Let us check using algebra. Instead of 3 and 4, let us take x, because x can take any value. If it is true for x, we can say it is true for all numbers. So let us take another isosceles right angle triangle where the base is x. We know these two sides are equal, so this is also x. Now let us find the third side. Third side is root of base square plus altitude square, or root of x square plus x square. X square plus x square is 2 times x square. So this can be written as root of 2 into x square. Root of 2 into x square is root 2 into root x square. And root of x square is x. So this can be written as root 2 into x, or root 2x. That means when the base is x, altitude is x, and hypotenuse is root 2x. So here again, the hypotenuse is root 2 times base or altitude. So we can say it is always true. Now let us observe the ratio of the sides. The base is x, altitude is x, hypotenuse is root 2x. So the ratio of the sides is x is to root 2x. In all the terms you can see x. So we can divide each and every term by x. Then we get x by x is 1. Root 2x by x is root 2. So this can be written as 1 is to 1 is to root 2. That means the ratio of the sides of an isosceles right angle triangle is 1 is to 1 is to root 2. Or the ratio of the sides of a triangle with angles 45 degree, 45 degree and 90 degree is 1 is to 1 is to root 2. Here we have to remember one thing, that we can draw isosceles right angle triangle of any size. For example, we can draw an isosceles right angle triangle, that is a triangle with angles 45 degree, 45 degree and 90 degree with base 5 and altitude 5, then hypotenuse is 5 root 2. We can draw a larger triangle by taking base 50, then altitude is also 50 and hypotenuse is 50 root 2. That means whether it is small or large, if the angles are 45 degree, 45 degree and 90 degree, the sides may be different, but they are always in the ratio 1 is to 1 is to root 2. So we can say the sides of any triangle of angles 45 degree, 45 degree, 90 degree are in the ratio 1 is to 1 is to root 2. Consider another right angle triangle. Suppose this angle is 30 degree. Then what is this angle? We know sum of the three angles is 180 degree. Since this angle is 30 degree, this angle is 60 degree. So this is a right angle triangle with angles 30 degree, 60 degree and 90 degree. Suppose this side is 3 centimeter. What are the lengths of other two sides? Here all the three angles are different and the length of all the three sides are also different. How shall we find the length of the other two sides? For that, let me take a copy of this triangle. Now flip it like this. Now place this triangle adjacent to the first triangle like this. Since this angle is 60 degree, this is also 60 degree. Since this is 30, this is also 30. This side is 3 centimeter, therefore this is also 3 centimeter. Now we have got a large triangle. Look at the angles of this large triangle. This is 60 degree, this is also 60 degree. This is also 60 degree. That means all the three angles of this triangle are 60 degree, means it is an equilateral triangle. Therefore, the three sides are also equal. This side is 3 plus 3 or 6 centimeter. Therefore, these two sides are also equal to 6 centimeter. Now, let us look at our first triangle. One side is 3 centimeter. Now we have got this side is 6 centimeter. So we have got two sides now. Now we can find the third side. We know altitude square equal to hypotenuse square minus base square. Here hypotenuse is 6 and base is 3. So altitude square equal to 6 square minus 3 square. 6 square is 36 and 3 square is 9. So this can be written as 36 minus 9 and that is equal to 27. The square of altitude is 27. Therefore altitude equal to root of 27. And we know 27 is 3 into 3 into 3. Therefore root of 27 equal to root of 3 into 3 into 3. For 2 3's we can take 1 3 outside and we will get altitude as 3 root 3 centimeters. That is, when the base is 3 centimeter, altitude is 3 root 3 centimeters and hypotenuse is 6 centimeters. That is, altitude is root 3 times base and hypotenuse is 2 times base. Is it always correct? Let us check using algebra. Let me take another right angle triangle with angles 30 and 60. Let the base be x. Now as in the previous case, take a copy of this triangle and flip it. Then we know it is the same triangle. This angle is 60, this is 30 and this is x. Now place it adjacent to the first triangle. Now we got a large triangle. We know it is an equilateral triangle. So all the three sides are equal. This side is x plus x or 2x. Therefore this is 2x and this side is also 2x. Now look at our original triangle. Base is x, hypotenuse is 2x. Let us find altitude now. We know altitude square equal to hypotenuse square minus base square. Here hypotenuse is 2x and base is x. So this can be written as 2x whole square minus x square. 2x whole square is 4x square. So this can be written as 4x square minus x square. 4x square minus x square equal to 3x square. Altitude square equal to 3x square. Therefore altitude equal to root of 3x square. Root of 3 is root 3. Root of x square is x. Therefore altitude equal to root 3x centimeters. That means this side is root 3x. When the base is x, altitude is root 3 times x and hypotenuse is 2 times x. Now let us find the ratio of the sides. X is to root 3x is to 2x. Each term can be divided by x. When x is divided by x, we get 1. When root 3x is divided by x, we get root 3. When 2x is divided by x, we get 2. So this can be simplified as 1 is to root 3 is to 2. That means the ratio of the sides of the triangle with angles 30 degree, 60 degree, 90 degree is 1 is to root 3 is to 2. As in the previous case, we can draw triangles of different sizes with angles 30 degree, 60 degree and 90 degree. Their measures may be different, but the sides are in the ratio 1 is to root 3 is to 2. Or we can say, in any triangle of angles 30 degree, 60 degree, 90 degree, the sides are in the ratio 1 is to root 3 is to 2. Look at this triangle. The angles are 30 degree, 60 degree and 90 degree. Let the base be 3 centimeter. Then this side is 3 root 3 centimeters and hypotenuse is 6 centimeters. Which is the smallest angle among these three? 30 degree. Which is the shortest side among these three sides? 3 centimeter, right? And you can see the shortest side is opposite to the smallest angle. Now look at the largest angle, that is 90 degree, which is the longest side 6 centimeter or the hypotenuse. And you can see the longest side is opposite to the largest angle. That means in a triangle, the shortest side is opposite to the smallest angle and longest side is opposite to the largest angle. Now let us recall what we have learned today. The sides of any triangle of angles 45 degree, 45 degree, 90 degree are in the ratio 1 is to 1 is to root 2. In any triangle of angles 30 degree, 60 degree, 90 degree, the sides are in the ratio 1 is to root 3 is to 2. Now there are some homeworks. The diagonal of a square is 4 centimeter long. Find the perimeter and area. Second problem. AC and BC are two equal chords with diameter AB. If the equal chords have length 10 centimeter, find the area of the circle. In the next video we shall discuss the remaining part. Till then, bye.